Hello guys, can you hear me? Hello, 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 hello. Can you guys hear me now? Give me some comments if you can. Cool. So I just taught the first 20 minutes on my own there, so and forgot to hit stream. So that was really good. Um, yeah. Anyway, let's start that again. So I'm gonna have to go a bit faster through this because I just wasted 20 minutes talking to myself. First thing of interest for you guys is that. How did I do that? That's awful. Grades you got in the mocks are going to be the grades we give you, even though we don't know if any of you kind of overinflated how you did. You know, if you had extra time or if you used your notes or anything. So only you will know what grade you got. But those are the grades, those are grades we're going to assign to you guys. We're just going to have to hope that you did authentically achieve those grades in the mock. So that's, well done to all of you, especially if you did do it properly. I think all of you, everyone I've marked so far. So I haven't yet marked Tristan, Ollie, or Scott's because yours came in late. But the rest of you all got A's and B's. So that's really, really good. Assuming that you all did it properly. I don't know. I'm not going to make guesses or allegations, but you might have done. You are a good class. So well done on that respect. But as I said, only you guys know if you did it properly or not. Yeah, we're moving on to the next topic, which is statistical distributions. So I've written this bit out. So statistical distributions are a way of describing the probability of any outcome in the sample space. So this is kind of moving on from probability, and we're now looking at ways of displaying and ways of dealing with lots and lots of values, taking lots of different probabilities. So that's the first bit. We're talking about the topic discrete random variables first, which is our first type of distribution. Next week we'll be looking at the binomial distribution, which is another thing altogether. And next year we look at the normal distributions. There's three types that we really look at in A level. So discrete random variables is the first one. And just to define that, discrete means, as we've seen before, they only take certain values in a given range, and random means the outcome is unknown until the experiment happens. All right, so I'm going to move on quite quickly today because I want to make back the 20 minutes I wasted. So, yeah, let's get rid of this a sec. So, right. The experiment we're going to do is rolling a fair dice. And the table that you can see in front of you, that is our probability. It's 2 seconds. I think I've got some hay fever. So, yeah, that's we call this our table showing you the probability distribution. And we've got little x at the top. So lowercase x, this is the value. Actually, let's start with capital X. So big X, and you can see in the bottom column of the table, we've got P big X equals little x. Big X is the variable. And our variable in the experiment rolling a dice is the variable is the number you get. So the variable is kind of like a title. It's kind of like a definition. The variable is the number that you get. Okay, it's kind of vague. Little x is the value. So it's the value the variable takes. So in this case, the value, well, we can have 1, 2, 3, 4, 5, or 6. In other words, I can have the variable could be the name of the student. Okay, it's like a title. The value would be Becky or George or Elliot, Billy, Callum, Jay, whatever. So the value is the value it takes on. The variable is the overall, the title of the thing we're looking at. And then at the bottom, this bit always confuses students. Probability x equals x, so big X equals little x, is the probability the variable takes a certain value. Which might seem obvious, and then we've gone through and we said, well, we've got these 6 values, 1, 2, 3, 4, 5, 6. Because it's a fair dice, the probability that the variable takes each value is the same and is 1 over 6. So just some definitions. The key bit though is this table. All right, so I'm going to ask you guys some questions, and I'm going to give you 10 minutes to do it, which is where I got up to. So I've managed to teach what I did in 10 minutes and 5, so I'm not actually too far behind. So I want you guys to try and work out, first one, the probability that x equals 5. So that's big X equals 5. So the value takes the variable 5. Second, I want you to work out the probability big X is less than 4. 3, probability X is less than or equal to 4. 5, the probability X is greater than 3. And 6, the probability X is less than 3.5. So can you give those a go, please, guys? I'll give you 4 minutes to do those. Could you comment your answers in the chat, and then we'll go through them in 4 minutes time. So 4 minutes starting from now. how did you get on, guys? So first one, probability x equals 5. So it's the probability that we roll a dice and we get 5. Well, that's pretty straightforward. That's going to be 1/6. Probability x is less than 4. Well, less than 4 means we're going to have all these 3. So it's probability of rolling a dice and you get less than 4. So it's going to be 3 out of 6. Wait for the iPad to catch up. So equals 3/6. Probability is less than or equal to 4. So now we can include 4. So that's going to give us 4/6. Or 2/3 if you want to simplify. Probability x is greater. Oops, I didn't get rid of all of that. That's right. Probability x is greater than 3. It's going to be those 3. So that's going to be 3/6. The probability x is less than 3.5. This is a bit harder. It's going to be those 3. So again, 3/6. 1/6, 3/6, 2/3. Yeah, nice, Jay. Perfect answers there. And Danny as well. Yeah, well done, both of you. Cool. So that's the basics of this. Yeah, another thing we could have is the cumulative. Best to keep it out of 6 or simplify. It doesn't really matter. You can simplify. All right, one point that rarely comes up nowadays, but it can come up, is cumulative probability. So we could add a column onto this table called F. F is the cumulative probability. So cumulative probability, well, the first one would be a 6th. Then we'd have 2/6, 3/6, 4/6, 5/6, 1. Notice the probabilities always have to add up to 1. That's still true in these tables. The whole table should be the whole sample space, so it should always add up to 1. So if I wanted to work out f of 5, what do you guys think I would get for f of 5? Have a quick think, see if you can comment your answers. Any ideas? F of 5. I don't know what the delay is like today. A few seconds. Any ideas? F of 5. Do comment when you got them. Yeah, nice, Harry. 5/6. So yeah, it's the cumulative probability up to 5/6. So we can throw that in as well. Nice. Yeah, everyone's commenting now. Bit of different delays on all of the videos. Okay, we're gonna try another question. So 3 coins are cost. 3 coins are tossed. Write down all the probability outcomes, and then a random variable is defined as the number of heads. Write the probability distribution of x as a table. Okay, so we're going to work through this one as an example because these are quite difficult at first. So 3 fair coins are tossed. What are all the outcomes we could get? Well, we could get heads, heads, heads. We could get heads, heads, tails. We could get heads, tails, heads. We could get tails, heads, heads. We could get heads, tails, tails. We could get tails, heads, tails. We could get tails, tails, heads. Or we could get tails, tails, tails. I think that's all. 1, 2, 3, 4, 5, 6, 7, 8. Does that work? I believe this is all the outcomes. Have a look through, guys, see if you agree with me, see if there's any other ones you can think of. Yeah, me too. heads or tails to the power of 3, 8. Cool, I think that's the lot. Okay, so those are our outcomes. We've got one outcome with all heads, one outcome with all tails. We've got 3 outcomes with 3 tails, 3 outcomes with 3 heads, 3 outcomes with 1 tail, and 3 outcomes with 1 head. Yeah, cool. Okay, so then we've said x is the number of heads. Let's write that down. And we want to write the table for that data. So I'm going to do this at the bottom. So x, what's the most number of heads we could get? Well, the most number of heads we could get is 3, so I'm going to put that up here. The least number of heads we could get is 0, and then we could get 1 head or 2 heads. So those are all the values that my variable can take. Okay, and then here we've got probability x equals x. So what's the probability of getting 0 heads? Well, there's one outcome where that happens, which is here. Out of a total of 8 outcomes, that's going to be 1 out of 8. Probability of 1 head, well, there's 1 head here, here, and here, so that's going to be 3 out of 8. 2 heads, 1, 2, 3 out of 8, and 3 heads, 1 out of 8. So again, we can do a quick check. Does it add up to 1? Yes, we've got 8 apes, so my probability does add up to 1. All right, so I want you guys to try a few of these. So, that's right, Kieran, try not to be as late next time. Can you guys define the probability x is equal to 3? The probability x is less than 2. Probability x is more than or equal to 1. And f of 2. So could you guys do those 4 for me? I'll give you 2 minutes to do it. Give it a go. That's right, Kieran. Do you want to go back to the beginning and watch it from the beginning? Okay, because big X column is the variable, small x is the value. So when we're saying that, we're saying that they're different things. Big X means variable, little x means value. So when I say it's the probability that the variable is less than little x, I'm saying the probability the number we get, the number of heads we get is less than 0 is an eighth. Probability the number of heads we get is less than 1 is 3/8. So does that make sense? It's the probability. Sorry, I shouldn't say less than. I should say equals in there. Probability x equals. It looks like less. Did I say less than? That should be the probability x equals x there. Right, have we got any answers? Anyone done them? And Callum, is that explanation okay? I want to make sure that you're happy with this. Cool. Any answers from people? Okay, so we got 1/8 for 3, Lucy. Yeah, good. 4/8 for 2, less than 2. Yep, 4/8, I agree. So let's write these down. So equals 3, 1/8, less than 2, 4/8, greater than or equal to 1, 7/8, and f of 2, 7/8. Nice. Good job. Okay, so we've seen one of these. There are 3 ways of showing a distribution. There's a table, which we just saw. So I'll write the one we just did as well. So we'll talk about the same situation. But x, px equals x. 0, 1, 2, 3. 1/8, 3/8, 3/8, 1/8 there. So the first way we can do it is the table as you've seen. The second way we can do it is something called a mass function, which I'll write out. So the mass function looks like this. The probability x equals x is, and then we have a big curly bracket. We write the probabilities first, and we write the x value second. I'm just going to redo that. Ran out of room a bit there. So the mass function, probability x equals x equals 1/8, 3/8, 0. And the next that we write x is, so which ones have a probability of 1/8? Well, x is 1 and x is 0 and x is 3. So we put 0 and 3. Which have a probability of 3/8? 1 and 2. And anything else has a probability of 0. So it's another way of writing the same information that's contained in our table, but kind of writing it as a function instead. Does that make sense, everybody? So we write the probabilities first, then we write the values second. And if any values share the same probability, we put them together with a comma. So that's what a mass function is. And then a diagram is basically a graph showing the probabilities. So the diagram, we'd put x on the bottom. So we'd have 0, 1, 2, 3. Then the probability on the y, so we'd go up to 1/8, 1/8, 3/8, 3/8. So again, same information, but a different way of showing it. So these are the 3 ways of showing your probability distribution. Table, mass function, diagram. So a question could ask you to draw one of these. It could give you one of these and ask you to convert it to the other type of these. But these are the 3 ways we can show those probabilities. Anyone got any questions about that? I know these can be quite confusing the first time you see them. Oh, okay. All right, we're going to try another one of these, and then we're going to do one more easy example, then we're going to do one that involves these 3 types of display. So I'd like you guys to try this. We've got a biased 4-sided dice with faces numbered 1, 2, 3, and 4. The number on the bottommost face is modeled as a random variable. Okay, so given that the probability x equals little x is k over little x, first of all, I want you guys to write the probability distribution, and then I want you to find k. So I want you to do those two bits in a different order, and then try part C. So I'm going to give you 4 minutes to do the first bit, find the distribution, and then I'll give you another 5 minutes to finish the rest of it off. So 4 minutes starting from now, just to work out what the table should look like. And you can do it in terms of k if you want, and that's going to help you define k as your second task. So 4 minutes starting from now. If you need any hints, please ask. I don't want you guys to stay stuck for 4 minutes. It tells you how to work them out. So it tells you the probabilities is k divided by x. So x, remember, is your value. So it's k divided by your value. So you can use that to use that bit to work them out. So yeah, the key bit column is that bit there. All right. So yeah, you got to look at all of it. So our table then, we know biased. Maybe it doesn't need to be that big. There's my table. X, P, X equals little x. So, four-sided dice, you can get a 1, you can get 2, you can get a 3, or you can get a 4. So we're told the probability is k over x. Well, for the first side, x is 1, so we're going to get k. For the second side, k is 2, so x is 2, so we're going to get k over 2, k over 3, and k over 4. How could I use this information to find k then? Any ideas? Have a think. See if you guys can work out how to find k. So if you want to try part B and then part C, give it a go. Now I'll give you 5 minutes to do all of those. But in 1 minute I will give you a hint at how to find k in case you're stuck. So see if you can find k yourself and then move on to part C. Yep, nice. They all add up to 1. So if you add all those things up to 1, you can then work out what k is. I think it should be something like... Let's just do it real quick. Let's do it. So if I add all those up, k plus k over 2 plus k over 3 plus k over 4 equals 1. I can work it out as 25 over 12 k equals 1. Therefore, k is 12 over 25. So you can use that to finish off your table. Which is going to be 12 over 25, 6 over 25, 4 over 25, and 3 over 25. Cool. Nice. Okay, yeah, that sounds right, Billy. You can do it as a fraction. Yeah, decimal's fine though. You can do it as a decimal too. Alright, so if you guys want to try part C then using those values, I'll give you another 2 minutes on the clock. See if you can finish them all off. Cool. All right, let's go through this then. So probability x is greater than 2 is going to be 7 over 25. So adding them up. Probability x is between 1 and 4 is going to be 10 out of 25 because we're only including the 2 middle bits. And the probability x is greater than 4 is 0 because it can't be. Right, is that all right with everybody? Elliot, your first character didn't type, but I'm guessing it's a 7. Okay, good. So next one, guys, is one I've made up. So find k, find the probability x is between 1 and 4, and then write a probability diagram and a probability function for this one. So I think we'll say 7 minutes for this one because it's got the part C as well. See how you get on. That word is right. Can you use a calculator for B? How do you mean, Karen? You're just adding together two numbers, surely. It's not binomial or anything. So yeah, you just you can add two fractions to calculate if you want to. Cool. All right. So to find k, we need to add them all up. So we get a third plus a third plus a quarter. And we're going to take that away from 1. Which gives us 1 over 12. So k equals 1/12. Find the probability x between 1 and 4, so we need a 12th plus a third. Which gives me 5/12. Alright, now we need to draw a probability diagram and a probability function. So the diagram, nice and easy. 1, 2, 3, 4. So we got the third, quarter, 12th. Like that. For the function, we're going to say probability x equals curly brackets 1/3 x equals 1, 2, 1/4 x equals 3. Sorry, my x's are coming out rubbish. And 1/12 x equals, oops, hang on, done that wrong. This is 4 there. X is 3 there, and 0 is otherwise. Cool. Everyone okay with that? Any questions at all? I think we might finish this today, you know. Maybe. It's gonna be tight, but I reckon, yeah, maybe we can get through this. Okay, does get slightly harder. And it gets slightly harder when we introduce a second variable. So, here's a probability distribution. I've left one gap in it. And we've given a second variable. So first of all, could you guys tell me, I've not made this very clear, is it? That should be 0.15 there. Can you guys read all those numbers? So could you guys first of all find the unknown probability, the blank one? Yeah, you always have to write 0 otherwise. It's just so that you've covered all eventualities. So you always have to do that at the bottom. Yeah, so could you guys find the missing value? And then we're told y, which is our second variable, is defined as 24 divided by x. So I'm just going to make some space. I'll write that again down here. Y equals 24 over x. So if you guys tell me the unknown, and then I'll talk you through the rest of this one. Yep, nice. Kieran and Billy, yeah, 0.3 is what we should have in there. Okay, so we're told y is 24 divided by x. We need to write a probability distribution for y. What I'm going to do, to make this easy, I'm just going to add y on top there. Because we're told the variable y is 24 divided by whatever x is. So to find my values for y, I'm going to divide 24 by x. So 24 divided by x equals 1 is going to be 24. 24 divided by 2 is going to be 12. 24 divided by 3 is going to give me 8. 24 divided by 4 is going to give me 6. 24 divided by 6 is going to give me 4. And 24 divided by 12 is going to give me 2. So I've used what it said. I've used this bit here to work out what the values are that y can take. So I can get rid of that now. So we've written the table for y. Yeah, I've used the same table. The probabilities are going to be the same because y depends on x. So the probabilities will just be exactly the same for y as they are for x. And now it wants me to find the probability that y is less than 25 whilst greater than 7. So can you guys try part B and C? Part C you might have some trouble with, so I'll give you 3 minutes to have a think about those two. No, maybe 4 minutes. We've got a bit of time. 4 minutes. Try those two. See if you can think your way through part C. I haven't told you what to do yet, but just see what you can come up with. Cool. All right. So probability that it's between 7 and 25. So 7 to 25 will be these three. Oop, I just erased it. Will be these three here, which is going to be 0.6. So, yep, Danny and Elliot, I agree with that bit. 0.6 there. Okay, y take 2x. So the easiest way to do these I always find is to add in a column y take 2x. And if you add in a whole column for it, it becomes super easy to see what's going on. So y 24 take 2x is going to be 24 take 2, 22. 12 take 4 is going to be 8. 8 take 6 is going to be 2. 6 take 8 is going to be minus 2. 4 take 12 is going to be minus 8. And 2 minus 24 is going to be minus 22. So those are my y take 2x values. And we want the probability that it's less than 0. So that's going to be these three. Those three are all less than 0. So 0.3 plus 0.1 is 0.4. Yeah, well done, Elliot and Danny there. Cool. Does that make sense, everybody? The last bit there, students always find a bit tricky at first, but I would just think add another column to the table. It's a new variable. Link them together and then look for the ones. So we are always using the same probability no matter what we do, because y is based on x. All right. Next one, this is for you guys to try and do all on your own. So tell me if you can read all this. I'm a bit worried my writing's a bit rubbish today. So it says write as a table. Then it says y is defined, capital Y is defined as x over 10 plus 2. Write the new table. Again, writing's a bit rubbish. Find the probability that y is less than 5, and then find the probability that x take 2y is greater than 19. So could you guys try this one? Let's say 5 minutes for this one. Cool. Comment your answers as well, please. Yeah, they always have to add up to 1. Looks like I've done something wrong with this question because they don't add to 1. let's try and fix that quickly. Sorry, guys. There you go. That should all work now. Cool. I gave you guys a bit more time there because I made a stupid question. I must have copied that down wrong because I did try this before and it was all working. Anyway, so first of all, write a table. So we've got x values are 10, 20, 30, 40, 50. Probability x equals x is going to be 0.2, 0.1, 0.3, 0.2, and this now does add up to 1. Okay. Okay, then it says y is defined as x over 10 plus 2. So we need to add in our y column there. So x over 10, so 10 over 10 is 1 plus 2 is 3. 20 over 10 is 2 plus 2 is 4. 30 over 10 is 3 plus 2 is 5. And it's going to keep on with that pattern. 3, 5, 6, 7. Find the probability that y is less than 5. So that's going to be 0.3. Yes, well done, Danny and Callum. And the probability x take 2y is less than 19. Well, let's add in that column as well. So x take 2y. 10 take away 6 is 4. 20 take 8 is 12. 30 take 10 is 20. 40 take 12 is 28. And 50 take 14 is 36. So the probability is greater than 19. So that's these three. So that's going to be these three probabilities: 0.3, 0.4, 0.5, 0.6, 0.7. Excellent. Well done, guys. Okay. I think we will stop there. I'm going to skip to the next slide and write A1C here. That's pretty good. It doesn't really get much more difficult, and that's pretty much that topic finished. We've got about another half hour of this to do next week. So next week we'll be continue with this and also make a start on the binomial distribution. As I said, well done in the tests. I will get the rest of the tests marked this weekend. And we will be doing a stats mechanics paper over half term. So if you guys could start revising your mechanics and make sure you're still doing assignments. Assignment 27 should be done this week, and the progress check 27 up on Moodle. And I will endeavour to get these marked as soon as possible. I've been pretty busy marking the mock papers. That's why I haven't got the assignments finished off yet. So, all right. Yeah, that's it. I will speak to you guys next week. Have a nice 3-day weekend. See you next Monday.